Alright, so in this video we're going to work through the S8P5 milestone review packet, and I'm going to give you some helpful hints to answer these questions. These are very similar to things that you might see on the milestone. So number 1 says, which of the following could be used as the core, so this would be the part that we wrap the wires around, to make a simple electromagnet? A pen, B, a drinking straw, C, an iron nail, or D, an aluminum wire. So think about what that core needs to have in order to make the electromagnet work and function properly. Number 2, which of the following can be used to decrease the strength of an electromagnet? So we're going to decrease the strength of the electromagnet. A, add more coils of wire. B, decrease the strength of the electric core. C, increase the size of the iron core. Or D, increase the strength of the electric current. So add more coils of wire, decrease the strength of the electric current, increase the size of the iron core, or increase the strength of the electric current. Number 3. Lisa has a copper wire, a bar magnet, and an iron rod. What can she do with these items to produce an electric current? A, place the wire near the north pole of the bar magnet. B, move the bar magnet rapidly, that means really fast, over the wire. C, touch the ends of the wire to the poles of the magnet. Or D, bring the bar magnet near the end of the iron rod. Sorry, you didn't get to see that at all. All right, number 4. Which of the following materials is most likely to be attracted to a magnet and then become magnetized itself? A, a piece of nickel. B, a rubber band. C, an aluminum wire. Or D, a copper wire. Number 5, which material could be used for the core of an electromagnet? A, a wooden rod. B, a vial of water. A vial is just kind of like a test tube or a graduated cylinder, just a container of water. C, a plastic rod. Or D, a nickel rod. And this is very similar if you notice. Question number 5 and question number 1 are very similar. Number 6, what does the iron core of an electromagnet do? A, it acts as a conductor, allowing more current to flow through the electromagnet. B, it acts as an insulator, protecting people from electric shocks. So we've got 2 words there, conductor and insulator. C, it produces a magnetic field that adds to the overall magnetic field of the electromagnet. Or D, it produces the electric current that passes through the wire coil. Number 7. An engineer built a device. The main part of the device is a bicycle attached by wires to a light bulb. When the engineer pedals the bicycle, the light bulb lights up. How can the device best be classified? Okay, so we've got a bicycle that the person's pedaling, going to wires that then go to a light bulb. And when the person pedals the bicycle, then electricity flows through and it lights up the light bulb. So is this a motor? Is this a generator? Is this an electromagnet? Or is this an armature? Great picture. All right, number 8. A student built a simple fan using an electromagnet, a permanent magnet, and a fan blade. When she connects the electromagnet to a single dry cell battery, the fan blade turns. How would the student's fan most likely change if she connected 2 dry cell batteries? See, before she had a single dry cell battery, and now she's going to double the amount of batteries that she's got. So A, the fan blade would turn faster. B, the fan blade would turn slower. C, the fan blade would turn in the opposite direction. Or D, the fan blade would not turn at all. So faster, slower, opposite, or not at all. Flip on over with me. Number 9. If you drop a sheet of paper, it floats slowly to the ground. If you crumple the paper into a ball and then drop it, it falls more quickly. Which of these best explains why the ball of paper falls more quickly than the sheet? So we've got the ball of paper that falls super fast to the ground, and we've got the sheet of paper that just kind of goes very slowly to the ground. This is fast. A, gravity affects spherical. The word spherical is referring to circular shapes. Spherical shapes more strongly than it affects thin shapes. B, air resistance affects an open sheet of paper more than a crumpled sheet of paper. C, crumpling the paper increases its overall density, so gravity exerts more pull on it. And D, crumpling the paper increases its mass, which results in greater acceleration from gravitational force. So C is referring to density, D is referring to mass, B is discussing air resistance, and A is talking about gravity's effects on spherical, circular objects versus the thin shapes. All right, number 10. A student performs 4 procedures using the same 2 magnets. In number 1, move the north pole of one magnet to 0.1 millimeter from the north pole of the other magnet to a 0.1 millimeter. 1 millimeter is not far at all. All right, B, move the north pole of one magnet to a 0.1 millimeter from the south pole of the other magnet. So here we have north to north, and here there's north to north, and here we have north to south. Okay, and they're 1 millimeter apart. Number 3, move the south pole of one magnet to a 0.5 millimeters from the south pole of the other magnet. Okay, so here we're south and we're going 5 millimeters from the other south pole. Draw these with me. And then in number 4, it says move the south pole of one magnet to a 0.5 millimeters from the north pole of one magnet. So south pole, 5 millimeters from the north pole. So which pair of procedures produces an attractive force between the 2 magnets? So look up here, look at our drawings. Which one of these would be an attractive force? Think about magnets and what attracts. Number 11, which of the following occurs in an electromagnet? A, an electric current is used to generate a magnetic field. B, a magnetic field is used to generate an electric current. C, mechanical energy is converted to electrical energy. Or D, electrical energy is converted into mechanical energy. And this is for an electromagnet. Electromagnet. Let the name kind of lead you in the right direction. Number 12. What happens to the force of gravity between 2 objects if the distance between them, here's 2 objects, if the distance increases? A, the pull of gravity increases. B, the pull of gravity decreases. C, the pull of gravity stays the same. Or D, the pull of gravity disappears. Number 13. In addition to distance, what factor determines the force of gravity between two objects? So we know that distance does. That's what this question was about here. So in addition to distance, what factor determines the force of gravity between two objects? Is it A, the volume of each, B, the mass of each, C, the diameter of each, or D, the chemical formula of each? Number 14, suppose you roll a basketball and a baseball toward each other. So you've got a big basketball and a little baseball. How does this affect, and they're going towards each other, how does this affect the force of gravity they exert on one another? A, the pull of gravity increases, B, the pull of gravity decreases, C, the pull of gravity stays the same, or D, the pull of gravity disappears. Number 15, what is the best explanation for why the moon orbits the Earth rather than the Earth orbiting the moon? A, Earth has less mass than the moon. B, Earth rotates faster than the moon rotates. C, the moon has no gravitational pull on anything. Or D, Earth has more mass than the moon. Number 16, which two factors keep Earth orbiting around the sun? Is it A, gravity and density, B, gravity and inertia, C, inertia and velocity, or D, mass and distance? Two factors that keep Earth orbiting around the sun. Flip on over to our last page. Number 17. Two balloons are rubbed with wool cloth. When the balloons are held near one another, they push away from each other. Why does this happen? So the key words here are they push away. A, the balloons have the same magnetic charge, so they repel each other. B, the balloons have opposite magnetic charges, so they repel each other. C, the balloons have the same electric charge, so they repel each other. Or D, the balloons have opposite electric charges, so they repel each other. Look at these keywords that I've underlined and select your answer. Number 18. Which of the following is evidence that a magnetic field surrounds a magnet? A, when a paper clip is placed on a bar magnet, it sticks to the magnet. B, when the north poles of two magnets are brought near each other, they push apart without touching. C, when a magnet is placed on a metal surface, it sticks to the surface. Or D, when you touch a metal doorknob, sometimes you receive a shock. Number 19. A magnet sticks to a table leg. Based on this information, which material could the table leg be made of? A, iron, B, wood, C, copper, or D, aluminum? Part 2 will contain 20 through